going to do all of chapters 3 graphing with every log graph as well. So, you have to know how to graph the parent graph of any log graph. To start off with, if the base is 4, this would be an exponential graph. And logarithms and exponential graphs are inverses of each other. So if you remember how to graph y equals 4 to the x, which I hope you do, then every exponential graph has 0, 1. And if the base is 4, you would have 1, 4. There would be an asymptote at y equals 0. And this one increases because of those 2 points. This is the shape of any exponential graph. And if you know the shape of any exponential graph, since logs and exponents are inverses of each other, all we would have to do is switch the x and the y. So instead of 0, 1, we would have 1, 0. And instead of 1, 4, we would have 4, 1. And instead of an asymptote at y equals 0, remember inverses switch x and y, so if I switch the x and the y, then I would get x equals 0, which would be a vertical asymptote. Now for this particular graph, we drew the exponential graph, did the idea of the inverse of switching all of the x and the y's to get your log graph. But I'm going to expect you to go directly, anytime you have a log graph, to have that shape, just like you've memorized what a parabola looks like, just like you memorized what an x cubed graph looks like. I want you to have the visual of a logarithmic graph in your head. And if it's base 4, you'd have 4, 1. If you had to graph a log base 3x, you'd have 3, 1. And so depending on the base, we could graph different log functions. Then in part B, it says, identify the intercepts. So there is an x-intercept at 1, 0, but because of that because of that asymptote on your y-axis, there's no y-intercept. Does it have an asymptote? Yes, it has an asymptote at x equals 0. What is our domain? Now your x values are bigger than or equal to 0, and your range is everything. Questions for practice on this one are 10 and 11, but we're going to add one more graph. So you have space, I think you have space on the page right across. I want you to graph y equals ln of x. And this is called the natural logarithm. So on your calculators, do you see your log button? And right beside it or right below it, they have an ln button. That's called the natural logarithm. So the log button, when nothing is written with the log button right here, it's the common log and it has a base of 10. When you have ln of x and nothing is written here, ln of x is a log with a base of the number e, which we got introduced to the other day. So if you are going to draw its graph, same as every log graph has the point 1, 0, and every log graph has the point, whatever its base is, 1, So the natural log graph would have e comma 1. Remember that e is 2.7-ish. You would have an asymptote at x equals 0. And it has the same shape as all of your other log graphs.